Good morning, guys. Today we're going to be looking at notes 1.06. This is graphing absolute value translations. And this is going to be our first lesson into transformations. The objective is to be able to graph absolute value transformations involving translations. And in math terms, translations means to move something, move an object. It can be a shape. In this case, we're going to be moving graphs, either to the left or the right, or up and down, or a combination, right? We can move something to the right and then up. So combinations of those four directions. And then we'll be able to write the equation of an absolute value function given its description. So we're going to kind of practice two skills in these notes. All right, so let's go right in. So first off, and let me zoom out a little bit over here. So here we're looking at the absolute value parent function. The equation we should be familiar with. The equation is going to be f of x equals these absolute value bars and then an x in the middle. And some of the key points that it had were points like negative 1, 1, 0, 0, and 1, 1. So that would be these 3 points. And the key feature of this one, we can pick like another set of points like 2, 2. Should be this one. And it would create kind of a V shape. So that's one of the key features of the absolute value, creating this V shape. The vertex is where the two lines meet. The x-intercept, same location, and the y-intercept is the same location. The reflectional symmetry over the y-axis. Right, this reflectional symmetry over the y-axis. We would say, yes, this is one characteristic. And then the minimum, again, remember here we would say minimum location is at 0, 0. That's the lowest point of the graph. And then domain is going from left to right. So there's an arrow on the left, so that's going towards negative infinity. Then there's an arrow on the right that's going towards positive infinity. And then range is going from bottom to top. So at the bottom, we're going as low as 0. And the arrows are going up towards infinity. So we're going to go from 0 with a bracket all the way to positive infinity. So the key thing is we're going to have 0 bracket. Okay, and again, these are just from past notes. And so just reminding us of these key characteristics of the absolute value. So let's keep looking down here. We read kind of some of the terms of this lesson. We're going to be looking at transformations. And a transformation is a change in the size or position of a figure or a graph. So it can be like a shape from geometry or a graph from Algebra 1 or Algebra 2. But if you change the size or position of that graph, what you're doing is called a transformation. The first type of transformation that we're going to look at is translations. They are called rigid transformations because we're only going to change the position of the graph. So let me highlight some key. If we're only going to change position, then it's kind of a rigid transformation, but the size and the shape will remain unchanged. All right. And so let's go over to the next part of the page of the notes. So over here we have this table, and this table kind of breaks down the transformations for us. Let me zoom in a little bit more. Okay, so this table breaks down the transformations for us. There's horizontal movement and vertical movement. And so we're going to look at different ways that the function can be written. And what we want to know is, what I want you guys to know is that when you write a function and they're adding or subtracting by a number, and notice that this letter h, this number that it's representing, is inside the parentheses, compared to these values over here are outside the parentheses. So depending on where they are, if the values are being added and subtracted inside the parentheses or inside the parent function, there's a horizontal translation. So just keep in mind, if it's inside, let me use a different color. Yeah, these values here are inside, so that means we have, horizontal. And if they are, let me use another color here, if they're outside of the parent function, then we have vertical. So that's what we want to take away from this table, some of the key features. And then, so we know inside values being added or subtracted are horizontal, outside values being added or subtracted are vertical. And then comes the other detail. If I'm moving horizontally, right, you have two options. You can either say you're moving to the left or to the right. If you're moving vertically, you can say you're moving down or up. So if you're moving to the left, or if the graph is being moved to the left, then you should expect to see, a plus sign inside the function. If the function is moving to the right, then you should expect to see a minus. And these are kind of opposite to each other, right? You think on the x-axis, if you're moving to the left, then there should be a negative number, right? But we got to think oppositely here. And also, if you're moving to the right on the x-axis, you think positive numbers, but we're going to think oppositely. The only one that's kind of straightforward is when it's saying to move down or up. And these are the outside values. But we'll look at examples and we'll kind of get a better handle on what it looks like. So let's just jump right into it. Let's look at this first example here. And let me make sure. Yeah, let me zoom out a little bit, just to make sure that the table's still in there, at least. Okay. So over here we have the parent function. It said graph the absolute value functions for these three examples. So we have the following function. Okay, so notice how it compares to the parent function. Remember, the parent function is f of x equals the absolute value of x. That's the parent function. But what I'm looking for is, what's happening over here. It's being added, you're adding to you're adding to, and remember the parent function doesn't have addition by 2. So what's happening to the function? We have a plus 2, and it's happening inside of these 2 bars, right? It's happening inside. So that tells us that the transformation is going to move the graph to the left. To the left, how many units? 2 units. So that helps us fill out the part about transformations. So as far as transformations go, we're going to say translated two units to the left. Translated 2 units to the left. And again, I'm using this part of the table, the fact that they're adding to inside of the function, inside of the absolute values. So inside means it's being moved however many units to the left. So translated 2 units to the left. And then points, we can plug in points. So what do you want to put as an input here? We can plug in 0. Right? If x is 0, so if my input is 0, then what's my output here? What's 0 plus 2? 2. Absolute value of 2? 2. So that's 1 point. Let's try plugging in another point, so another value. Let's try -1. If I plug in -1 into x, what's -1 plus 2? That's +1. What's the absolute value of +1? +1. Let's plug in -2. So I'm going to plug in -2 for x. So what's -2 plus 2? That's 0. What's the absolute value of 0? 0. So what the absolute value is doing is it's just making whatever the numbers are, it's changing them to a positive number. Okay. Let's do one more. Let's go -3. So from -2, I want to put -3 as my input. So what's -3 plus 2? -3 plus 2 is -1. But what's the absolute value of -1? Remember, the absolute value just takes any number and makes it positive. So if I want to know the absolute value of -1, it's just going to be 1. Okay. So let's plot these 4 points. So move up here. And I'm going to, what color should I draw it in? I'll do it in red. Or no, I'll do it in blue. Okay, so 0, 2. 0, 2 is right here. So I'm going to put a dot right there. Next one is -1, 1. The next one is -2, 0. The next one is negative 3, 1. So that's negative 3, 1. Let's do one more because I want you guys to see what shape is going to happen here. So let's do negative. Let's keep going to the left. So what's after negative 3? Negative 4. So let me go back to my list of points, and I'm going to add negative 4 over here. So let's input that into the equation. Negative 4 plus 2. Negative 4 plus 2 is positive. Negative 4 plus 2 is negative 2, but the absolute value of a negative number changes it to positive. So it's going to give me positive 2. And then I'm going to graph that point. So negative 4, 2. And look what shape comes out. It's still the V shape that we know. But now, what happened to that graph, right? Remember, the parent function used to be right here. So if I draw the parent function, I'll draw it and then I'll erase it. Oh, no, that's fine. I don't know why these came out kind of shaky. Okay. So the purple function is the parent function, right? This blue function is this graph over here. So I have the parent function and I have the transformation function. So what's different from the purple and the blue, right? It's the same shape, just that it's been moved to the left. How many spaces did we move it? It's 1, 2. So it still keeps the same shape. It's just been moved. See, I'm waiting for the pen to load. It's not. There we go. Okay. So now we can answer a couple questions about the graph. What's the vertex of this graph now? Where do these two lines meet? What's this location? It's negative 2, 0. Now some other things change, right? It's asking about the x-intercept. Where does the graph intersect the x-axis? Well, it's at the same location as the vertex, right? It hits the x-axis at the same location where the two lines meet. Now there's a change in the y-intercept. Before it used to be the same, right? Now the question is, what is this point right here? Let me use a different color for it. So I want to know, where does the graph hit the y-axis? It's at 0, 2. 0, 2. This point is at 0, 2. So I'm kind of changing the color because now we're talking about a different point. Okay. Do we have a minimum or maximum? Well, we don't really have a maximum because the arrows are going to keep going up, but we do have a defined minimum. So I'm going to say that we have a minimum. I'm just going to put min. Domain, going from left to right, it's still going negative infinity to positive infinity. So nothing changed there. But now, actually nothing changed in the range either, because if we go from bottom to top, what's the lowest that it goes? 0, and the highest? Infinity. So it's still 0 to infinity. All right. Now let's switch over to example 2. All right, example 2. What's happening here? Now we're subtracting. There's subtraction happening of 3. There's a subtraction of 3. So it's still the absolute value, but it's minus 3. Okay, so that means that transformation is that there's a translation (3 units). And the question is, which direction is it going to be moving in? Keep in mind that this is being moved outside. And so outside means a vertical movement, and so we have to decide if it's moving up or down. Is it moving up or down? Minus 3 to me means down. So 3 units down. That's the transformation. And then the next step is to pick some points. Let's pick some points. So let's pick negative 2. So if I plug in negative 2 here, what's negative 2 minus 3? Well, remember, the negative 2 that I'm plugging in is inside of the absolute value. So think of it this way. Let's do kind of a test. Right, so I'm going to do the absolute value of negative 2 minus 3. So what's the absolute value of negative 2? That's positive 2, and then minus 3. That's going to equal to negative 1. So my output is negative 1. All right, let's try another one. Let's try negative 1 is my input. So what's the absolute value of negative 1, and then subtract 3? The absolute value of negative 1 is 1. Then subtracting 3 equals to negative 2. Okay. Let's try plugging in 0. 0 minus 3. So if I plug in 0, 0 minus 3 is negative 3. What about 1? If I plug in 1, what's 1 minus 3? Negative 2. Let's do one more. What if I plug in 2? What's 2 minus 3? Negative 1. Okay. So let's plug in these points. Let's start with this one. Negative 2, negative 1. Actually, let me zoom out a little bit, just enough so we can see the graph. Okay. Negative 2, negative 1 is going to be negative 2, negative 1 right here. Negative 2, negative 1. Next one is negative 1, negative 2. So that means left 1, down 2. The next one is 0, negative 3. 0, negative 3. The next one is 1, negative 2. 1 to the right, down 2. And then the last one, 2, -1. That means to the right 2 and down 1. What do you know? The shape that we get. It's this absolute value shape. Ah, make this a little bit straighter. Huh. Is it still the same shape as the absolute value? Does it have this V shape? Yes. But the couple of points that I drew out caused a translation of 3 units down. So even though I put a translation of 3 units down, when I plugged in different numbers, right? I plugged in -2, I plugged in -1, I plugged in 0, I plugged in 1, and I plugged in 2, right? These were all my inputs, and each gave me a different output. But as I graphed it, it creates the V shape, but instead of doing whatever the parent function does, which the parent function would start here and go out like this and like this, right? This is the parent function in purple, but this function that I graphed is the same thing but just moved three spaces down. So it's being transformed by being moved 3 units down. And so we can answer things about the vertex, right? What is the vertex? It's at 0, -3. The x-intercept. Well, now we have 2 x-intercepts. So let me use a different color for those. We have an x-intercept here and here. So that's going to be at -3, 0 and 3, 0. It's for the x-intercept. For the y-intercept, it intersects the y-axis here, so that's at 0, -3. Is there a minimum or maximum? We have a minimum, right? A lowest point. The domain from left to right, we have arrows going to the left, we have arrows going to the right. So that means from -infinity to +infinity. The range. How far to the bottom does the graph go now? It goes as low as -3 and all the way up to infinity. So we're going to go bracket -3 all the way up to infinity. Okay, and just to let you guys know, I just use the color red over here, not to say that this is the same idea over there. So I'm going to change the color on the top because I don't want you guys to think I'm. So I changed it to pink up here. But the x-intercept has nothing to do with the -3. The -3 just tells us that there's a translation down 3. So I'll do that in pink. So we do kind of an arrow. Okay. Right. And let's do one more graphing example. And now this one combines two transformations. It's combining uh, horizontal and vertical, because we said, if they're adding or subtracting a number inside of the parent function, that's a horizontal movement, outside is vertical. Okay, so outside we have +1, so that's a vertical translation up. And then let me use a different color. Over here, we have a horizontal translation. And here we want to think opposite. So I know that we want to move 4 units, but it's going to be 4 units if it's minus, instead of thinking to the left, it's actually going to be to the right. 4 units, right? Okay. And this time, let's do the points first. Okay, we're going to do the points first. And we're going to go right. So let's do 2. What happens with 2? So if I analyze what's happening with 2, it's the absolute value of 2 minus 4 plus 1. So x minus 4 plus 1, so I'm going to do 2 minus 4 plus 1. 2 minus 4 is negative 2, but the absolute value of negative 2 is positive 2. So it's 2 plus 1, which is 3. And then we're going to try another point. Let's do, so my first one I chose was 2. Let's go to the next point up. After 2 is 3. So let's try an input of 3. Input of 3. What's 3 minus 4? Negative 1, but the absolute value of a negative 1 is positive 1. So it's 1 plus 1, which is 2. Okay, let's go up one more. Oh, I want to keep it one there. 4. 4 minus 4 is 0, plus 1 is 1. Let's go 5. So instead of writing it out, I'm just going to say what's happening over here. So we have, what's 5 minus 4? 1. 1 plus 1, 2. Alright, and then let's do one more. 6. What's 6 minus 4? That's 6 minus 4 is 2. 2 plus 1 is 3. Right, so let's graph these points. 2, 3. 2 comma 3 means 2 to the right, 3 up. The next one is 3, 2. 3 to the right, 2 up. The next one is 4 to the right, 1 up. The next one is 5 to the right, 2 up. 5 to the right, 2 up. And the last one is 6, 3. So 6 to the right, 3 up. What do I end up with? Another V shape. Another V shape. So we have this parent function provides kind of the V shape. And remember, again, the parent function was the graph that did something like this, right? It went up here and then it went over here. So what changed? How would you describe the movement here? So for sure, the transformation was a translation. So I'm going to say translated, because we didn't change the shape. We just moved it around. So it was translated. It looks like it moved 4 steps to the right and 1 up. So I'm going to put translated 4 units to the right and 1 unit up. So 4 to the right and 1 unit up. And this blue graph is my transformation graph. I'm sorry for these pauses, but I'm waiting for the program to load because I'm changing tools and I want to select a pen and it's loading. All right, here is the vertex where these two lines meet. So the vertex, let me do it in purple. So that vertex is at location 4, 1. Does the graph intersect the x-axis? No, right? So we would say none, or there is no x-intercept. Y-intercept, the graph, even though I drew an arrow there, it's going to keep going. So I can keep this line. Again, it's loading the blue pen. Okay. So if I keep drawing this line because there's an arrow, it's going to hit the y-axis at this location. So it's going to be 0, 5. So let me choose a different color. This location is 0, 5. 0, 5. Right. The next question, does it have a minimum or maximum? It has a minimum. Domain, the arrows are going to the left to negative infinity and to the right towards positive infinity. So the domain is negative infinity to positive. And then the range, what's the lowest that the graph goes? It goes as low as 1 and as high as infinity. So as low as 1 and as high as infinity. Okay, so that's that for the graphs. Then there's 3 more examples. It's these 4 right here, and so I'll break them up. Let me zoom out a little bit. Okay, so here in these last 3 examples, we have a couple of statements, and based on the statement, we're going to write an equation with the given information. So first information, well, actually all of them have the same parent function. So I'm going to say, the parent function is, in equation form, is the absolute value of x. It's the absolute value of x and the absolute value of x. Okay. What's different is the transformation that's happening to them. So I'm going to try and use kind of a color code. So if it's a horizontal movement, in this case to the right, I'm going to use green, and it's going 3 units to the right, so we're going to do -3. And the thing about horizontal movement, it does the opposite number, because again, if you're looking at the x-axis and you're looking at the number line on the x-axis, let's say I draw the number line, so I have 0, 1, 2, 1, 2, and then -1, -2, something like this. So if I'm looking at the x-axis, you would think if I'm going to go to the right, then I'm going to get positive numbers, right? And if I'm going to go to the left, I'm going to get negative. And it says 3 units to the right, so you think that you're going to put +3, but we actually put negative. And so the thing is that for horizontal movement, we write the opposite value. Okay, so how's that going to look as an equation? It's going to be f of x equals the absolute value. Another thing about horizontal translations is that they happen inside of the function. So it's going to be, like I have the absolute value symbol, and then I have an x inside, and then the -3 is also going to be inside. Okay. The next one has a translation of 5 units up. So that's a vertical translation. So that's going to have, that number is going to happen outside. So it's going to be something like f of x equals the absolute value of x, and then the 5 is going to be +5. I'm going to write +5 because it's moving up. And for vertical translations, which is happening outside, it's going to be directly what it is. Because if you think of looking at the y-axis, if you move up, then the numbers are positive as you go up and negative as you go down. So we're going to write +5 outside. Right, and then the last one here, we're going to do horizontal and then vertical. So we have vertical, we have horizontal, and then we have the units. So remember, vertical is straightforward. If it says 7 units down, then down means negative, up means positive. Down is negative, up is positive. So it's going to be -7 because it's down. And then 1 unit to the left is going to be it's going to be, instead of thinking of a negative number, it's actually going to be a positive number. So it's going to be +1. And so it's going to be, the equation is going to be f of x equals the absolute value, so that these 2 bars of x, where the plus 1 is going to be inside and the minus 7 is going to be outside. Okay, so if I write everything in one color, it would be, my equation would be like this. And I'm just drawing it or writing it in color so we can break down. In blue, I'm writing, what the parent function is. In green, I'm writing the horizontal transformations, and in purple, I was writing the vertical transformations. Plus 1 and minus 7 with absolute value here, absolute value. Okay, so I'm going to be answering questions next time in class. So I'll see you guys in the next class. And if you have any questions, or if you want me to go over any ones in particular, just let me know and we can go over it in class. Thank you for joining me today, and I hope you have a great rest of your day.